And we're off. So, today we are going to talk about more with the derivative, our introduction to the derivative. And the derivative is also known as the slope of the tangent line, or the slope of the tangent line is also known as the derivative. And we've talked about this in class today, that we use the notation f primed, and the definition is it's the slope of the tangent line, which is the slope of the secant line with the limit, f of x plus delta x minus the f of x all over delta x. Okay, so there's that piece involved, and the other notations that we'll use from time to time are dy dx, y primed, and then the derivative of the function. So we use all sorts of things, all different notations, and just so you get used to it interchangeably, we'll use the word derivative, slope of the tangent line, instantaneous rate of change. They all mean the same thing. We all go about finding them the same way. All right, so we're going to use the definition of the derivative, and this is the definition of the derivative, to find the derivative of, and I don't know why that keeps coming up, but I'm going to make it stop. Find the derivative of this function. Okay, so what we're doing, I've got it typed here for the first little bit, but then we'll get into it in a little bit. Is we're taking this function. Yeah, this is the function we're using, and we're putting it with this definition. Remember I said foreshadowing? So x plus delta x goes in everywhere there's an x. Everywhere there's an x. So as I look at this, I have x plus delta x cubed, okay, plus 2 times x plus delta x. That's this part here with the x plus delta x in. Subtract away the original function, x cubed plus 2x, all over delta x. Okay, so what I've just done is I've taken the function, plugged it into this definition of the derivative. That's a start. Okay, and if you realize, if I were to plug in delta x going to 0, I'd get 0 over 0, the indeterminate form, which means we have more work to do. Okay, and then I think you have this all on one page, so feel free to not keep writing this stuff over. So we've got to expand out x plus delta x cubed, and we're going to use Pascal's triangle. Remember Pascal's triangle? We've talked about it recently, and again, that was that foreshadowing thing. Pascal's triangle. So third row, we're going to use 1, 3, 3, 1. And we're going to start with x cubed, and then go to x squared, and then go to x, and then we're going to start with delta x cubed on the other end, delta x, I'm not giving myself a lot of room, squared, delta x, all are going to be plus. Okay, that part is just the expansion of this, so we've got that taken care of. And then plus 2x plus 2 delta x. And then we're going to subtract the original function, and I'm going to get rid of the parentheses, x cubed minus 2x. All of that over delta x. So you have all of that stuff, and I'm going to just kind of scroll down the page here. I'm not going to switch to the next thing. So we're using Pascal's triangle to expand, and then we're going to simplify. Okay, so simplify. One thing I will notice, and let me get a different color ink out so we can be clear. I've got an x cubed here, and I've got an x cubed there. Gone. Someplace in here I got a positive 2x and a negative 2x. So those are gone. So now I've simplified this down to what, 1, 2, 3, 4 terms. And I'm going to suggest that as you're doing this, you write out as much of this information as you can, just so we don't lose things, because there's a lot of places to lose stuff. 3x squared delta x plus 3x delta x squared, and I put in parentheses because we're squaring all the delta x's, plus delta x cubed plus 2 delta x, all of that over delta x. Okay, what's beautiful is that all of these things now have a delta x, and I forgot, I'm taking the limit as delta x approaches 0. So again, if I just start plugging in delta x 0 on all these, I'm going to get 0 over 0. It means we still have more work to do. So all these have a delta x, so I can factor delta x out of all of these terms. Delta x, so what's left on the first term is 3x squared, and then I've got a 3x delta x, and then I've got a delta x, which is plus delta x squared plus 2. All of that's over delta x, and we're still taking the limit as delta x approaches 0. Hopefully you're not trying to squeeze this into one box. You got the whole page. Okay, so now, bit of boom, bit of bang, blue ink, cancel, cancel. No longer are we dividing by 0. Now we can find the limit as delta x approaches 0 of this whole blue ball of wax. Says with much emphasis in his brain. Okay, oops, that still wants to be a plus. Plus 2. Okay, when delta x is 0, really go bold with the blue. Delta x is 0, that's 0, right? That's 0. Is this affected by delta x? No. Is that affected by delta x? Ultimately, we end up with 3x squared plus 2. Ta-da! We have found, I'm going to skip ahead, simplify, find the limit. So that's all the stuff we did. You had all this on the same page. So we found that the limit of x cubed, or the derivative of x cubed plus 2x was 3x squared plus 2. Okay, so what that means is we've got some sort of function. Okay, remember derivative is the slope of the tangent line, and I'm just going to pretend it looks like that. I don't know, no, it doesn't really matter. But the slope of the tangent line, anywhere I draw this thing, let's get me a line that I can move around. The tangent line is going to change. If I have the tangent line right here, it's going to be this way. If I have the tangent line, I don't know, like somewhere else, like over here, it's going to be different. So as I move through this function, the slope of the tangent line changes. That's why there's an equation for the slope of the tangent line, because it's not just like a linear function where the slope's always the same. Okay, talking really fast because I'm excited. How did we do on that first problem? 6 minutes 38 seconds. Perfect. Next problem. Could take us 9 minutes. So same thing. We want to find y prime for y equals 2 over x. This is a little bit more difficult because it's a fraction and a rational function, and we got to go right for it. So what we do, take what's in the parentheses, plug it into the function. Let's get me a pen. Let's get a blue pen. Okay, need it on this page, but I'm going to just plug 2 x plus delta x. That's right here. 2 over x plus delta x. And minus my original function. That's this original function. All over delta x. So I've just replaced the f of x plus delta x with that there and then that. So I've just rewritten the function with x plus delta x in it. We've got us a fraction this time. So we need to have a common denominator. I don't really feel like rewriting that. I'm going to be extremely lazy. Not lazy. I'm going to be extremely efficient. I'm just going to copy this over. You have it all on the same page. What's the matter? I can't do that. Let's see if I can. Let's see if it'll let me paste it on there. Not that I'll have to do something else. Edit, paste. Great. Tricked you. Alright, so we're going to use a common denominator. The way to get a common denominator is just to multiply the two denominators together. So in this case, my common denominator that I'm going to end up with is x times x plus delta x. Okay? That's going to be my common denominator just for the top part here. Okay, what I'm missing in this first term is I'm missing an x, so I got to multiply top and bottom by x. That's 1, right? Top and bottom by x. And this one I'm going to multiply by x plus delta x. X plus delta x. Doesn't like it when I go fast like that. Okay, that's multiplied by 1. That's multiplied by 1. That's always legitimate. So this part's going to be 2x. This part's going to be minus 2x plus delta x. I just multiplied those across, okay? And then I've got all over delta x. Okay? Still taking the limit, I don't have room to write it, so I'll write it right down here. The limit as delta x approaches 0. Okay? I've got on the top, I've got 2x minus 2x minus 2 delta x. All over x times x plus delta x. All that's over delta x. It's not looking any better. But, good news, 2x minus 2x, gone. Okay, got me a better looking fraction, not much better looking, negative 2 delta x over x times x plus delta x. All that's over delta x. So it kind of looks like I've got me a nice English. I've got us, we have a fractiony thingy. That's even worse, but we have a complex fraction, fraction divided by a fraction. So I'm just going to look at that as delta x over 1. Okay? So I end up with a fraction, sorry, divided by a fraction, so I'm going to rewrite that as such. Negative 2x times x plus delta x divided by delta x over 1. Still, I want the limit as delta x approaches 0. Okay? Still going to be a problem, so let's go one more time. Negative 2 delta x over x times x plus delta x times, right? Because we can do that, 1 over delta x. Okay, wonder of wonder, joy of joys, I got a delta x on the top and a delta x on the bottom. They are now evaporated into the ether, into the internet. Delta x goes to 0, so I'm left with negative 2 over x times x plus delta x. Okay, and so when delta x goes to 0, this whole thing is worth just x. The bottom is x times x, which is x squared. So I'm left with negative 2 over x squared. Okay, a little more complicated. Let's kind of roll back through. Get that common denominator, which we get just by multiplying the denominators together. Simplify, 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 simplify. Ultimately get to a point where we have some delta x's to cancel out, because that's the thing that's 0. If we can get rid of those, our life becomes much happier. Then we can just evaluate, and then we go. Okay, so turns out, oops, there's the simplify page. So the limit and the derivative is negative 2 over x squared. Maybe that's going to be on the next page. No, it's not. All right? So we will do some more of these. These are difficult because of a particular problem. Now, any of these problems that I've asked you to do here, okay, requires, well, lots of things. It requires, first of all, like the idea of a slope and the limits, and it required Pascal's triangle, and it requires just somewhat keeping track of the signs of things, and then factoring and all kinds of things. So there's a lot of little places to make little tiny mistakes, and we're going to practice with these for a couple days so that we get to the point where we're pretty efficient at doing them. It all comes down to the definition of the derivative. That's what we're working with. Definition of the derivative. Learn to love it, learn to remember it, learn to have it in your brain. F prime of x is the limit as delta x approaches 0 of the f of x plus delta x minus the f of x, all that over delta x, gives us the derivative. This is the assignment here. I don't think you can see it. That's okay. We'll talk about it tomorrow. It's pretty small right now. Won't get much bigger once we get there. Hey, thanks for sticking with us here for 12 minutes and 52 seconds or so. It's difficult. You can do this. Or maybe it's not difficult and I'm just making stuff up. But we can do this. We'll get better at it as we go. Hopefully you learned something. Hopefully we can make it good tomorrow. See you then.